Morning. Sorry for the technical difficulties. I actually talked this a little bit in my interview, and Tom Chan looks like very interested in it. So that's probably about why I got hired. Uh, and Ryan told me that so he is a New England fan and he always chooses New England players. So he probably doesn't need this. He's always going to be doing pretty well. So today. So I'm going to talk about when machine learning meets fantasy football. This is actually one of my school project. See here. See. All right. All right. So according to the Washington Post in 2015, fantasy football actually produced 1.5 billions of revenue per year. And now we're at the area where you have a bunch of data and you have an output. You can probably apply some machine learning algorithm to make the computer does the prediction for you. So why not use machine learning to predict fantasy football? So to tackle a machine learning problem, first we have to define the objective. Right, it's a little laggy, but so compare with like the season-long fantasy football form, daily fantasy is more suitable for machine learning because it's more about statistical analysis compared with like trending and long-term analysis. So that's what we're going to be working on, and we are using the rules from I think DraftKings. So basically every week you have a limit budget, you pick your lineup, and then the most point you get out of your team actually wins in your group. So to make it work, we have to do some assumptions and define a goal. So our assumption is that the player's priority and skill doesn't really change during the season. And to apply machine learning on different positions on the team, actually we'll have to create different features. So to limit our scope, we're actually gonna be focusing on running backs, and then the goal is to predict the points that the running back is gonna score in the coming week. So then we need to have our data. We need to collect the data and prepare our data. The raw data we're using is from FF Today and Football DB. And we're going to be focusing on the top 25 running backs for 2014 season to use them as our sample data. So after some processing of our raw data, we come up with those features. The first category is basically a game context. Is a home game or away game. Second is the players' performance, their rushing attempts, rushing yards, receptions, and receiving yards. Third is basically how the player is prioritized in their team's offense. Is the team a rushing team or a receiving team? Also, we consider the opponent's performance. So how many rushing yards and receiving yards the opponents actually allowed. So we use those data, and then we calculate the moving average of the previous 1 to 8 weeks. So we use that also as a hyperparameter to do our predictions. All right, it's not responding. Okay. So our setup for our model is we have 286 samples. We run each algorithm 10 times with random order samples, and then we have a train validation test ratio of 60%, 20%, 20%, which is pretty typical. Because we are predicting a quantity, we use the regression estimator, and we use some basically popular regression models. So simple ordinary least square, we have ridge regression, super vector machine regression. And we use a combination of k-mean clustering and OLS, which I'll talk a little about later. The program is written in Python using scikit-learn, pandas, and NumPy, just some popular machine learning libraries. Then we run train validation test. So the first algorithm we run, where it goes here, yeah, it's OLS. So actually, oh, 1 second, I think we skipped one. Yep. So before we in that, actually, we do a feature selection. So basically, we have like P features, and then for each number feature, we calculate. So we select the features that actually gonna produce the best fitting for our regression line. Then in validation, we pick those features that give us the smallest prediction error. So here's the result for our OS. So the x-axis is the moving average weeks that we use to calculate, and the y-axis is the prediction error. So what we found out is that each run we have different selective feature, but those three, the rushing errors, passing reception, and the opponent's defense against rushing appears the most. So that tells us that those are the most relevant to our model. The second algorithm we run is ridge regression. So those are the results. Third is super vector machine regression. We use those 5C values as hyperparameters, and those are the results. So the last one, so by observing our feature data, we figure that there are actually different types of running backs. So there's ones that are what they call workhorse, which they use. So they are most used in a rushing game, and they are played in most downs. And then we have some receiving running backs, which their stats most coming from receiving yards. So so I say, well, let's run some clustering. So we run k-mean clustering to form those cluster of different type of running backs, and then we apply OS on top of that. So this is the results. So in summary, our prediction model actually outperforms human experts, which I'm kind of proud of. But so the LS and SVR actually predicts the best results. Still, it's very difficult to do prediction on fantasy football stats because there are a lot of variables, and I think our model actually have a decent is a decent alternative to experts. So in terms of feature works, I think we can consider more factors and also explore more more complex models. That's all. Thank you.